can expand, and as Zand already indicated, we can expand into pine, and we already are doing it. But it's really novel work that we're engaging in and setting a base to go on for further work and expand our research base. So very exciting. I haven't seen any other questions pop up, but please do use the Q&A to engage our researchers and challenge them a bit. And I also please invite you to engage with the researchers in this program. As Yolanda said, that the project that Dave is running is providing us with a long-term laboratory in the field. And I know Dave is very excited for anybody to join that initiative, to utilize data that's coming from there, or to initiate research on that, so we can actually exponentially increase the value of what we're doing by combining resources. So with no other questions popping up, I'm not going to hold Yolandi busy for much longer. Yolandi, once again, thank you very much for presenting it and representing the team, as you indicated, from Jacob, Louis, Xander, Dave, and yourself and Mary. Thank you very much for that. We do appreciate it. We then are moving directly into our next presenter. Once again, an area that Flick identified this morning is a big concern for us is water availability and water use. And the moment we start understanding these dynamics better for our growing crops, it not only positions us better to address climate change, as Yolanda expressed, with some areas becoming much drier, but this also positions us with information to address any legislative challenges our industry has faced and probably will face into the future. And to tell us a bit more about this is Dr. Nkosinathi Kaptein. I think familiar to a lot of us. Nkosinathi cut his teeth in forest research at the ICFR and came up to the ranks and expanded our research footprint and our forestry education footprint after moving to the University of Mpumalanga, where he is a lecturer in the School of Agricultural Sciences. So on that note, Nkosinathi, thank you very much. Look forward to your presentation and telling us a bit more about the new work that's happening in forest hydrology. Thanks, Nkosinathi.
Thank you so much, Ronald, for an introduction. Good morning, everyone. I'm just going to share my screen. Okay, yeah, thanks for an opportunity to present on this platform. So the project that I'm going to be talking about this morning is a project that looks at the water use and water use efficiency on eucalyptus species in the Mpumalanga province. So we have quite a big team of people who are working in this project. So it's a sort of a collaboration between the University of Mpumalanga. There are some members from UKZN, and then also ICFR is involved. We also have got a student who is doing a master's, a hair master's on this project. So I thought that the first thing to do is just to remind you about the importance of the forestry industry. As we all know, that it plays a very big role in contributing to the agricultural GDP. It provides us with a lot of with some employment, and also it decreases the pressure on indigenous forest destruction, because now instead of using indigenous forests for our forest products, we are using commercial forests. Also, it provides some aesthetic benefits, which contributes immensely into the tourism industry. There are other benefits that are usually overlooked, which includes the fact that commercial forest plantations, they reduce soil erosion, particularly because they develop that thick layer that thick litter layer, which then reduces the velocity of the water, therefore minimizing erosion. Also, after canopy closure, we know that they reduce soil evaporation, improve infiltration rates, and then there are many studies that have indicated that commercial forests mitigate air pollution, and they also mitigate the impact of climate change. So if we look at the distribution of the commercial forestry industry, most commercial forest plantations are located in the Mpumalanga province, as you can see from this map, closely followed by KwaZulu-Natal, and then we have got other plantations located in the Eastern Cape, Limpopo, as well as the Western Cape. But what I want to mention here is that although Mpumalanga is one of the provinces in South Africa with a lot of commercial forest, there are limited studies that have been done in this province, in the Mpumalanga province, to try and understand water use by commercial forest plantations. So if we look at the studies which have been done here in Mpumalanga, also in other provinces, we have learned that those studies indicate, or the results from those studies indicates that trees use more water than other vegetation types, such as grasses, the shrubs, as well as the indigenous forests. As a result, currently the South African commercial forestry industry is regulated under the National Water Act, number 36 of 1998. So the Act basically declared commercial forest plantations a stream flow reduction activity. And currently, the industry is regulated through a water use licensing systems. So this regulation, the declaration took place in 1999, which was 25 years ago. So now the species that were used in terms of doing this declaration are species such as Eucalyptus grandis, Pinus petula, as well as the Acacia mensa. So now in this presentation, I'm only going to be looking at the eucalyptus, not the other two species. So if you look currently, the industry is in the process of either phasing out species like Eucalyptus grandis, and then they are going to more new genotypes such as Eucalyptus dania, Eucalyptus grandis pyurophylla, Eucalyptus night, and then many other species, because they've got good pulping properties, they've got resistance to certain pests and diseases, just to mention one of the few reasons. So this then suggests that there is a knowledge gap. So there is a need to understand how much water do the species that are currently planted by the forestry industry, how much water do they use? So what we are trying to do in this project then is to bridge that gap. So why the study? First point, we want to try and expand the water use knowledge by eucalyptus species that are currently planted by the commercial forestry industry. But we also don't want to just understand how much water trees use. We also want to increase the knowledge in terms of the water use efficiency. Thirdly, we also want to develop transpiration coefficients so that we can model water use from automatic weather station variables. So the equipment that is used to conduct measurements of water use usually is very expensive, and it requires specialized skills. So we want to develop transpiration coefficients that you can use to model water use, and then we hope also that from developing those transpiration coefficients, they can be used in future modeling studies, more complex modeling studies in the future. They can contribute there. So the first step then that we had to do after we have identified the problem was to find the study sites. Where are we going to do this study? So we identified our study site in Sapi Plantation in Kapsehoop in Nelspruit. At this stage, we tried with trees. Well, we decided to go with trees that are 6 years old. We have identified one site at the moment, which is planted to 6-year-old Eucalyptus dania. As you can see on the picture from your right there, the bird eye view. We implemented the trial in March, beginning of this month, 2024. And the reason why we also chose this site is because it is adjacent to a site where Nelson Mandela University is conducting water use on Pinus petula as well as Pinus eliota, of which we are collaborating with them. So we thought that if these sites are right next to each other, then we can probably do also a comparison in terms of the water use of eucalyptus versus pine. And then we are also planning on introducing a second site. That one we still need to identify where we will measure the water use and water efficiency of Eucalyptus grandis by Europhila. So now looking at the study site one, we used a heat ratio method. We used a heat ratio method to measure water use. On the picture on your left, you can see the probes there that are planted into the tree. What we also do, because we don't want to use just a single set of probes, we install 4 probes per tree to try and account for water use at different places within, or at different depths within the sapwood, so that we can catch the sap flow throughout the stem. On the far right of your screen, you can see our student there, MSc student Zako, who is putting a fence around one of our trees, because this site unfortunately has got a lot of baboons and they tend to pull the probes out of the tree. So we've just put a fence around each and every tree that we're measuring. So this method is only capable of measuring 4 trees, and then we upscale those 4 trees into a stand level. And I must state that this is an internationally recognized method, so it's used internationally. So we are also conducting other supporting measurements. On your right there, you can see an automatic weather station, which we are then going to try and develop transpiration coefficients from. And then we are also conducting the supporting measurements, growth, leaf area index, soil water content, and canopy interception, which will help in terms of understanding our water use and water use efficiency. So now, what is the value of measuring water use in commercial forest plantation? The first one is that we want to contribute knowledge on the refinement, possibly refinement of the licensing systems. I think the South African water legislation will have to undergo a series of refinements at some point as the research results and simulation models improve, particularly with the new species, with these new genotypes now that are planted by the commercial forestry industry. So I've indicated before that if you look at the SFRA, it was mainly developed from the species, the older species that are being phased out or they are no longer planted by the industry. Also, we want to improve management practices to achieve long-term commercial forestry industry sustainability. You remember from my first slide, I indicated the importance of the forestry industry to all of us in terms of all the products that we use every day. So we want to make sure that the industry becomes sustainable. So a project like this, we hope that it will contribute into that in making long-term commercial forestry industry sustainability. We have also learned that most of the markets where the forest products are being sold, now they need guarantees of producing trees in an environmentally sustainable practices. We hope that a project like this will also add to that. It will indicate to the markets that the forestry industry wants to make sure that things are done or trees are produced in a sustainable manner. And lastly, we want to make sure that we want to understand how the genotypes adapt to climate change. and to longer water stress conditions. So we have observed climate abnormalities in the recent years, which are putting a lot of stress on many eucalyptus plantations due to higher mean annual temperatures, more intense rainfall events, and the periods of more water stress, and even extreme weather events. So we are hoping that this research is going to give us an understanding of how the new genotypes are adapting to that. I've also mentioned that we will not only look at the water use, we are also interested in the water use efficiency. We are hoping that the knowledge that we'll get from here will guide the eucalyptus tree breeding programs in terms of what is it that can be done to improve transpiration efficiency in eucalyptus to make sure that the trees, they acquire more biomass in exchange for the water transpired by the crop. But also we don't want them to just be water efficient. We also want to produce eucalyptus trees that will partition more of the biomass into the harvested product, because at the end of the day, the reason why we are farming trees is because we want to make money, and the money comes from the stem wood, which is the harvested product. And hopefully, lastly, this will contribute to understanding if the trees that are being bred, they've got a reduced total water use. That's what we are hoping this is gonna contribute. So we are open to suggestions, and also we are open to collaborations in this project. Thank you so much.
Thank you, Nkosinathi, for an excellent overview and clearly expressing the need for this type of research. We've got one Q&A in at the moment from Mr. Gerrit Maree, asking about the statement that there is little research available on water use in commercial forestry. Nkosinathi, would you like to respond to that?
Yes. So if you look at, by that I mean that if you look at the species that are, in fact, the top, I'll say top 3 species that are currently planted at the moment, to our knowledge, Dania, GN, GU, there is a very limited knowledge. In fact, the most recent work that I'm aware of is in the KZN. Most of the work that was done has been done in other species, such as Grandes, Nitens. To my knowledge, there is a very little work that has been done with the most recently or currently planted species.
Thank you, Nkosinathi. Yes, I think keeping in mind the diversity of our planting stock, the soil diversity, geographical diversity we deal with, the little work that has been done is definitely not representative of water use of the sector, as I think that's as not Nkosinathi alluded to. I also think that past research was focused on just two species, one for pines and one for eucalyptus. And since the new technologies like the heat pulse method and the ecovariance methods have been implemented, we still need a significant expansion on our knowledge of water use of our diverse planting stock in our diverse areas. I think also the big challenge is competitive data to other crops that we compete with. For example, sugarcane and also your citrus industry or your tree farming industries or tree fruit industries. So that is a big gap for us. I know that the Water Research Commission is spending quite a bit of money in that area, but it will take us a lot of time to get a decent understanding of the diverse water use of our trees in South Africa. Let me just quickly have a look. There's more questions. There's a question from Xander. Should we not look at root development? Perhaps dangerous to only focus on stemwood production? Nkosinathi?
Yes, so I agree with Xander. It's very important to look at the root development. That's why I said that we are open to collaborations. If there is a project that can look at the root development, that will be very useful. Because I think that is, well, at this stage, we are unable to look at the root development in the study because they tend to be complicated, and then we are only focusing on the on the water used by trees. But that will really help.
Thanks, Nkosinathi. As you see, there's also in the chat box a request for the presentations to be shared. As we generally do, once we've concluded today's event, we will ask the researchers or presenters for permission to share their presentations as well as their contact details. So we'll keep all the participants of today informed when they get posted. Any other questions? It's just maybe sure there's no new questions. Okay, wonderful. Nkosinathi, thank you once again.
Excuse me, sorry, Ronald. There appears to be a question from Professor Mary Scholes in the Q&A box.
Okay, it hasn't popped up on my side. Katie, can you just maybe read that for us, please?
Absolutely. Professor Scholes asks, how are you scaling up the sap flow data to whole tree and compartment?
Yeah. So ideally, we would like to measure more than 4 trees because that will increase our confident limits. But because of the resources and well, at this stage, we are only able to measure 4 trees. So we have got a spreadsheet that has been developed by a team from UKZN, where we are basically so the way our HPV is designed is that we measure different size trees. Like the 4 trees that we're measuring, we measure 4 different size trees, which represents the small, the medium large, and the large. And then what we do in the rest of the compartment, we measure growth measurements. What we then do is that we try and correlate or we try and estimate water used by the rest of the trees using growth data from the growth that we've measured, like diameters and height. And then we are then able to upscale it from 4 trees into the stand level.
Thanks, Nkosinathi. I'm sure that does answer Mary's question. Maybe just to add that some of the work that was done by Mark Gush, where they were able to do a bit more multiplexing and measure more trees per compartment with different sizes as well, and then comparing that with idiocovariance measurements, have also shown that it is quite representative on compartment level, specifically in clonal compartments. Of course, in seedling compartments, that does change a bit, but on clonal compartments, we've seen very good correlation. That 4 trees do represent a quite accurate measurement of stand water use as well. But I think that has been, in quite a number of publications, been expressed as some of the challenges with this type of work is the heat pulse method relies on probes, and you can't extend the distance of those probes too much because it starts affecting your measurements. That limits the number of trees that you can actually measure, and the equipment used for that is quite expensive. So to measure more trees does get quite inhibitive due to the costs. But new technologies are being developed through the Sector Innovation Fund and the project that Yolani presented earlier. We've already touched base with individuals that's developing probes that are significantly cheaper and smaller to use. So as technology gets advanced, I think we'll be able to improve our coverage of measurements. So thank you for the question, Mary, and Katie, thanks for bringing it up on my attention. If there's no other questions, colleagues, we then can, I think,